So now let us understand how the sleeper spacings will be provided and what is the how the sleeper density has to be maintained. So now we all know what is the spacing of the sleepers. So spacing is nothing but these all the rails and the sleepers what you have provided. So the distance between the two consecutive sleepers, that we call it as the sleeper spacing. Okay, so that is what given here, the space between the two adjacent sleepers. Okay, that we call it as the sleeper spacing, and that sleeper spacing will determine the effective span of the rail over the sleepers. Okay, and also the space of the sleepers in the track depends upon the axle load which the track is expected to carry, and also the lateral thrust of the locomotive which it is subjected. Okay, so usually the number of sleepers is expressed in terms of number of sleepers per rail length. So that means to say that usually the what is the length of rail, so that depends upon whether it is broad gauge or meter gauge. So usually the broad gauge will have the length of 13 meters. Now for this 30-meter length, how many numbers of sleepers we require? So that is what it says. Okay, so the number of sleepers in the track is nothing but how many sleepers you need to be provided for one particular rail length, and the length of the rail that depends upon whether it is a broad gauge or meter gauge. Okay, and since the sleepers also provides the lateral stability to the track, more the number of sleepers, more will be the lateral stability. However, we cannot simply increase the number of sleepers definitely, as there is a certain minimum space between the sleeper is required for the packing of the ballast. Okay, so we have to maintain that minimum spacing for the ballast so that it can effectively transfers the load to the ballast. Okay, so now how many sleepers need to be provided, what is the maximum number, and what is the okay, so that will be defined with respect to the sleeper density. So number of the in India, so what number of sleepers what we have provided, nothing but the sleepers density that is provided with using the relationship that is between the what number of sleepers you provided, that varies from m plus 4 to m plus 7 for the main tracks. So now what is this m plus 4, where m is equal to length of rails in meter. So if the length of rails is 12 meters, so what is the number of sleepers that require? Sleepers will be equal to 12 plus 4 to 12 plus 7. So what number we will get? 16 to 12 plus 7 is 19. So we require number of sleepers will vary between 16 to 19 for a rail length of 12 meter. So that is what it says. So with that we can define the sleeper density as what is the number of sleepers per rail length. Okay, so that we call it as the sleeper density, and it is specified as m plus x, where m is equal to length of rail in meters and x is the a number that will vary according to the factors. So in India we have fixed the value of x is in that will be in between m plus 4 to m plus 7. So depending upon the lateral thrust or the stability of the track was being expected. And one more thing, more the number of sleeper, more will be the lateral stability. Okay, so some of the factors which will govern the sleeper density or axle load. More the axle load, more the sleeper density, more will be the value of x. Speed, type and section of the rails, and type of the ballast used, and the ballast cushion, type and strength of the sleepers, and nature of condition. So all these factors will govern the value of x. Okay, the space, and also the spacing between the sleepers is not uniform. Okay, so throughout the length of the track, we don't provide the uniform spacing. Okay, so usually 3 to 4 sleepers on either side of the joints are kept close together. So how does it turn? See, this is my first rail section. We have a joint at this point and it is continued with the next sleeper. So usually in the middle the equal spacing is maintained, but when it comes to close to the joints, 3 to 4 sleepers are placed at the closer spacing. Okay, because the joints are the weakest point, since the impact load will be caused here, that additional stability is required. So that is why the sleeper spacing is reduced when it approaches to the joint section. Okay, so depending upon the sleeper's density, the spacing of the joints can be fixed. Okay, so we'll look into the example, one of the example for the calculation of how the sleeper density is calculated. So they are given it as found out the expression for the sleeper density. So how do you get the general expression is m plus s? So we have to determine this. So find out the expression for sleeper density on a broad gauge track if 19 sleepers are used under the rail length. So for the broad gauge track, what is the length of the sleepers? So we'll say about 13 meter, and the sleeper density is expressed as m plus x. So now the number of m is the rail length and x is the factors that depends upon that. So that is what we have to find out. So in the problem they have given if the track 19 sleepers are used, nothing but the sleeper density. Sleeper density is 19, with length of the track is 13, plus we have to find out the value of x here. So x will be 6. Okay, so that's the expression for the sleeper density will be n plus 16. So if you substitute value of length plus 6, that will be equivalent to the, so that is how you can obtain the value. So this value will become 19. So we can obtain the sleeper density with the help of this expression. So another example is they have given sleeper density value is given. We have to find out the number of sleepers required for constructing the railway track of 640 meters. So they have given the length of track is 640 meter long. Okay, so now what the sleeper density, when we calculate the sleeper density, that we will calculate number of sleepers per rail length. So now for one rail length, how many sleeper we will get, that you calculate. Okay, and next for 640 meters, how many rails is required. Okay, that need to be determined. So multiply those two values, you will easily get how many numbers of sleepers is required. So we'll take the total track length is 640 meter. For the broad gauge track, the length of the track is 12.8. You can even take 13 meters. So total number of rails is required. What is that? 640 divided by 12.6. So we require around 50 number of rails for 640 meter long railway track. So they have given the expression for the sleeper density as m plus 5. So substitute the length of the rail. So we will get it around number of sleepers under each rail. Under one rail we require 18 number of sleepers, but we have 15 such rails to cover 640 meter length. So total number of sleepers required will be 18 multiplied by 50, that is equal to 900 sleepers. So this is how, with the having the expression for the sleeper density, we can calculate the number of sleepers required in the construction of the railway track. Okay, so and last thing is the sleeper density can also be expressed in terms of number of sleepers per kilometer. So this will be used when the railway tracks or joints are welded. Okay, so depending upon the short, whether the track is short welded track or the long welded track. So we have the sleepers density. So sleepers density can be around 1660 meter per kilometer for the center to center of the spacing of the sleepers. Okay, so that should be around 60 centimeter. And we require 1540 sleepers per kilometer, having a spacing between the 65 centimeter. Similarly, if it is for the short welded track, the same sleeper density, but the distance between the two sleeper is 66 centimeter. And whereas the when we have one more sleeper density providing 1310 per kilometer of the railway tracks, but there is no recommendation here for long welded tracks. So because we cannot use that, only this sleeper's density can be used for the short welded track, having a spacing between 78 centimeter. So this is how we can provide the sleeper spacing when construction of the railway track. Thank you everyone.